Okay, so AS Physics, the most recent paper we have at this time at least, that's Feb March 18. Special cameo appearance by Ashad, which is good because I don't remember AS Physics, but I believe he does. Well, he should know AS Physics at least. Okay, so one, which unit is equivalent to the coulomb? Now, the coulomb is the unit of charge, which you to charge Q. Now, and basically, let's look at a few formulas from where we can try to figure out a unit. So Q is equals to NE, but I don't think that gives us an appropriate unit because N is just the number of electrons, E is the charge of one electron. So like, I don't think that will give us an appropriate unit. However, Q is also equals to IT. Now that may give us amperes into seconds, and that could be a possible answer. But unfortunately, it is not a possible answer. In fact, they're giving you amperes per second, which is different. So like,
Yeah.
not this, but I think we can look at another formula though. Potential difference was work done upon charge. In fact, I think this will give us our answer. So charge is work done upon potential difference. Work done is in joules. Potential difference is in volts. So joules per volt, you get B, and you're good. Two, which row shows a quantity and an incorrect unit? So we can basically just cross out the rows that show correct units. Efficiency does have no unit because if you think of efficiency, what was efficiency, Ashad? Power?
It's the ratio of power input, useful power output upon power input.
Yeah. So the idea here, if whether you're taking power output, power input, or work done output, work done input, the idea is the units will just cancel out from the numerator and the denominator, leaving you with no unit. Let's look at B. Obviously, if this is a correct unit, you can cancel this out because they want an incorrect unit. So
Incorrect.
let's look at B. They want the moment of force. So moments was force into perpendicular
This.
distance, yeah, from the fixed point to the line of action of force, which gives you Newton meter. Uh, Here it's wrong because it's Newton per meter, so you can just take this. If you want to go through the other options, work done is obviously in joules, so you can just leave that. Momentum, I believe they use the other formula here. How how force is equals to what was it? The rate of change of momentum.
Rate of change of momentum.
Yeah, and you just rearrange that, you get Ft, which is Newton second. So even this is correct, which is why B is your answer. Okay. Two forces of equal magnitude are represented by two coplanar vectors. Ashad, what are coplanar vectors?
Acting in the same plane.
Yeah. So basically, think of it like this: like for our intents and purposes, like they're both on the page. They're not coming. One's not going to be coming out of the page. One's not going to be going into the page. Nothing like that side. Nothing like that.
So like acting in two dimensions only, no?
Basically, so like X and Y, they don't have your Z axis. They're just in the same plane. Okay. So one is directed towards the east and the other is directed towards the north. If we quickly make our compass, this is north, this is south. Um, and I used to remember this through V because I always used to get mixed up with west and east. So just remember it has to spell V. Anyhow, so one is directed towards east and the other is directed towards north, which means your resultant would be something like this, given making a 45-degree angle because they're of equal magnitude. If you don't get this, if you don't get this, you can look at it like this. Think of it like this. This is the one towards the east. This is the one towards the north. And this is the resultant. So maybe now it's easier for you to visualize why that's the resultant. What is the direction of a single force that will balance these two forces? So you just have to balance the resultant or cancel out the resultant. So you have to act in the opposite direction to the resultant, which is basically southwest. You're good to go. Do you have a calculator on you, Ashad?
Yeah, I do.
Okay, good. See. So the density of paper is this much. A typical sheet of paper has width 210 millimeters and length 300 millimeters. The thickness of a pack of 500 sheets is 50 millimeters. What is the mass of a single sheet of paper? Now, if you think about this, you have density. Density is mass upon volume. You have density. You can calculate volume because you have the dimensions, and hence you can figure out mass. So if you first figure out volume, volume is, it's like, I believe this is more like a rectangular sheet of paper. So it's length
I
in,
think पहले volume of 500 sheets निकालेंगे हम लोग
um,
because
I think you
we
can
don't
do it.
have the thickness of.
Yeah, so I think you can either do volume of 500 sheets, or alternatively you could just figure out the thickness of one sheet. Because
Yeah,
if the thickness of 500 sheets is
with-
like 50 millimeters, then the thickness of one sheet will be x, giving you 50 upon 500. That will be the thickness of
yeah,
one sheet in millimeters. So where was I? Length into breadth into height. Length is what? 300 millimeters. So do convert it. Breadth is 210. Height is whatever this is coming out to be. And do remember to
1
convert it. So just divide every single quantity by 1,000 to get meters, because uh, here it's
as 3 times 0.1 into 10 minus 3, 6.3 into 10 minus 6.
okay. So you're getting 6.3 into 10 to the power minus 6. This is in meter cube because we have converted it. Now,
Converting.
yeah, so now basically for mass you just multiply this with your density from this formula here. So that's into 800. Let's do that.
3 10 minus 6 times 800. 5.04 into 10 minus 3. So 5 grams.
Basically. So if you remember, this is in kg because we converted it into meter cube. We used the units of density that were kg per meter cube. So this is in kg, and as Ashad said very quickly, in fact, uh, if you multiply this by 1,000, which is basically you just remove the minus 10 power minus 3, you get grams. It's closest to 5 grams. Um, okay. A person calculates the potential difference across a wire by using the measurements shown. Which measured quantity has the greatest contribution to percentage uncertainty in the calculated potential difference? Interesting. Now, how would we calculate potential difference? So maybe using V is equals to IR. However, we don't have resistance in the options here, so maybe we can replace that with the formula for resistance. Do you remember that?
Rho, rho
Rho L
times L over A.
upon area. But I don't think we even have diameter here. So let's express that in terms of
So like
diameter. It's basically pi d square. If you assume that it has a circular cross section, which most wires do, so that would be pi
yeah,
d square over 4, giving you pi d square, and 4 just goes up.
yeah,
So if you wanted to calculate the percentage uncertainty here, you'd kind of be taking absolute uncertainty of I upon I plus, the same thing for rho upon rho, and same thing for L. The only interesting thing here is the fractional uncertainty of D would be twice as much because of the square
yeah.
function. And then you just add all of them, you'll multiply by 100. So I believe, in fact, what should we do
As
now?
in you
Yeah.
add the fractional uncertainty of L2.
Bichara L. Okay. Okay. Say. So, I think then whichever variable has the
Whichever is the largest, that contributes the largest, right?
what?
Whichever of these fractions, like uncertainty in I over I, uncertainty in L over L, 2 times the uncertainty in D over D, and the uncertainty in rho over rho. In 4 fractions में से जो largest होगा, that would be the answer because that contributes the greatest.
Basically. So for that, we'll figure out the percentage uncertainties for each of these particular quantities. So Ashad, if you could go ahead with that. So basically what you're going to be doing, you're going to be taking if I do it for A, you're going to be taking your absolute uncertainty upon the value and going to be multiplying that by 100. I believe this is 10.
Yeah.
I it's a
B
difficult.
is 12.5. No, B is 12.5 times 2
That's important because D again, this is uh, because of the square function,
square.
you're going to multiply by 2. So this is 25 uh, percentage uncertainty.
The length is 5.150. Length is 3.3.
Okay, so don't really care that much about that.
Or resistivity is 12.5.
Okay, and in fact, if you had forgotten the square function, if you had forgotten to multiply diameter by 2, like the uncertainty in the fractional uncertainty by 2, then you would have been getting the same answer for B and D, leaving you
Yeah.
a rather confused person in the exam. Anyhow, because B has the greatest individual percentage uncertainty, it will have the greatest contribution to percentage uncertainty, and that's that.
In the
Yeah. So there's a CRO. It's connected to an alternating voltage. The following trace is produced on the screen. And they've given you the time-based settings. They're basically your x-axis settings, if it isn't already known. Y plate is more of your y-axis settings. They've given you those, and they've asked you which statement is correct. So one, the amplitude is 3.5 cm. If you want to look at the amplitude, this is the mean value because it goes equally up and equally down from this value. Amplitude is like this. This is 1, 2, 3, 3.5 centimeters. Um, Ashad,
seems correct.
yeah, it does, but can we express amplitude in centimeters or do we have to express it in volts?
I think we should express it in volts.
Right? Because if you really think about this, the
Yeah.
relationship between time and centimeters in the x-axis and volts and centimeters on the y-axis is just to help you show it on the screen. But in reality, the graph is actually a volt or whatever against time graph. That's the reality. So your
In
amplitude will be something in volts. So if they had said
volt.
this was 7 volts, I would have agreed with that. But with 3.5 centimeters, probably not. If it had been like a displacement graph, then it makes sense to give your amplitude in centimeters because then you have
Yeah.
distance on your y-axis. B now, so B and C both will use your time period. So let's just calculate that. Ouch. Anyhow, so your time period is basically gonna be the time it takes. Okay, that was some noise, but it's gonna be the time it takes for one complete wave to
Yeah.
go
So
about. So
4 blocks.
yeah, so 1, 2, 3, 4. Now we know that each block is worth 0.5 milliseconds, which means 4 blocks is 4 into 0.5, giving you 2.0 into 10 to the power minus
Mil-
3 seconds, because I just included 10 to the power minus 3 for your milli. Now clearly that shows that it's not 1 millisecond, so you can cross out C. For B, you have to do frequency is 1 upon time period, which gives you
500 hertz,
so
which
500.
is technically
Yeah.
kilohertz.
So if you divide that by 1,000 to get kilohertz, you'd get zero point 0.5. And that's why the correct answer is B. And again, with D, they're doing the same mistake. They're trying to confuse you by saying, okay, the wavelength was 4 boxes, so that's going to be 4 centimeters. No, here the x-axis is clearly your time, and that,
Time.
yeah, you can't really make that relation. So that's why A and D were wrong. Okay. A stone of mass m is dropped from a tall building. There is significant air resistance. The acceleration of free fall is g. When a stone is falling at terminal velocity, which is basically constant velocity, which is basically, if it's falling at constant velocity, then you know there is no acceleration. There is no resultant force. And just by that, you can figure out.
A wrong. Okay.
Yeah, A is obviously wrong because the acceleration has to be 0. Anyhow, the magnitude of the force of gravity on the stone. Now, if there's a stone and it's falling in your gravitational field with mass m and gravitational field g, So weight will be magnitude of the force of gravity. What is the force of gravity? That's weight, right? So weight will be acting. You can't say weight is zero. Um,
Hmm.
and weight is mg. And in fact, a lot of people might make this mistake. They might be like, no, but there is no resultant force. But understand, just because there isn't a resultant force, that doesn't mean weight isn't acting. Weight is acting. It's just balanced out by your air resistance.
Air resistance.
Yeah. So weight is what? It's mg. And air resistance, since it has to balance out weight in order to ensure there is no resultant force, it obviously has to be equal to weight, right?
Hmm.
It has to also be mg,
Yeah.
but just in the opposite direction, just in the upward direction. So you can go with B.
Hmm.
The velocity time graph for an object is shown. How can the total displacement of the object be determined? Um, so for a velocity time graph, you used to figure out displacement by looking at the areas, or at least with distance. Now with distance, you just add the two, but here, this is positive velocity.
It's
This is negative velocity, which means in the backward direction. So kind of like basically your distance, you've gone area one like this, you've come back area two like this. So your overall displacement is the difference between the two, which is basically area one minus area two, giving you A, right?
yeah.
9, a ball, sorry, not a ball, a girl throws a ball vertically upwards. It takes a time of 3.2 seconds to return to her hand. Assume air resistance is negligible. What is the initial speed by which the ball is thrown? I don't know. Uh, what?
Okay, so it's like 3.2 seconds पूरी journey के लिए हो गए to
Okay.
reach 0 meter per second, like the top point 1.6 seconds लेगा.
Okay. Okay. So go from her hand to the point where it's at its maximum point and it has zero velocity and then starts to come back down. You said it's 1.6 seconds. You divide that by two, basically. Okay. So this is where
And
V.
then the acceleration equals v minus u upon t, right?
Yes. So we know your
V unknown.
yeah. So you can keep
Huh?
acceleration as g, right? Uh, you can keep v as zero because at that highest point, your final velocity will be zero. You can keep u unknown. You
If,
can keep t as
listen, listen,
1.6.
listen.
Yes.
If you're taking v as 0, then you're gonna have to take g as acceleration as minus g.
Um. Sure. Uh. Yeah. I didn't really,
I think it matters that much.
because you're talking about speed, right? But yes, you would have to, so that your value of, yeah. But basically, like, yeah, he's right. So whenever you're throwing something upwards, you take minus g, I believe, and whenever something downwards, you just take g. Um,
So get 15.7.
15.7. Okay, so you get
Yeah.
C by taking G as 9.81. And in fact, remember one thing, because I remember when in my AS, a lot of people used to be really confused with this. So what I was taught, and hopefully Ashit can verify that, is if you're looking at a particular motion, so whether that's projectile motion or whether it's some simply throwing balls up in the air, to understand whether you need to take g as negative or positive, you look at the first instant. So where you're throwing it the first time. Is it going downwards the first time? Is it being dropped from above? Then it's positive g, and you take positive g for the rest of the journey. If it's projectile motion and you're throwing it up, you're going to take negative g, and you're just going to take that for the rest of the journey. Do you agree with that?
Huh.
Yeah. So
Yeah, I do.
because a lot of people used to make the mistake. Suppose this is projectile motion. This is not related to the question, but just generally, they used to be like, okay, for this part here, it's minus g. This part here, it's positive g. But then they used to use time for the entire journey though. So if you're taking the entire journey as a whole, then you're just going to take it as negative g because that's where it started off as.
Yeah.
Okay, so steel pellets, they have mass of 0.6 grams. They fall vertically onto a horizontal plate at a rate of 100 pellets per minute. They strike the plate with a velocity of 5 and rebound with a velocity of 4. And they want you to figure out what is the average force exerted on the plate by the pellets. Okay, so
तो change in moment निकालेंगे.
that was quick. Okay, so like force is your rate of change in momentum. So let's try to figure out the change in momentum. That's going to be your mv minus well, mv1 minus v2, where like v1 is basically how they're striking, so that's 5, and v2 is how they're going. Now this is something that a lot of people mess up, in fact. Yeah. So if v1 is 5, and now you've basically taken positive side, right? You've taken the downward direction to be positive, which means the upward direction has to be negative because it's in the opposite direction. So this has -4. So basically what this becomes, this is whatever mass was, let me just take mass as constant, I don't really care about that. This is now 5 minus -4, which means it adds, which means it's 9m. A lot of people just subtract this for some strange reason. So it's 9 into m is 0.6 grams. But if you want it in newtons, I believe you have to convert it. So that would be into 10 to the power minus 3.
10 minus 3, yeah.
What are we getting?
5.4 into 10 minus 3.
So we're fine with momentum. Now, the only issue here is if we knew the time it takes for one pellet to go and bounce back, we'd be fine. But we don't know for one pellet. We know that it strikes at a rate of 100 pellets per minute. So I believe there are a few ways to do this, but the way I think that's going to be simple is just you calculate the change in momentum for 100 pellets, and then you just divide it by the time it took for 100 pellets, which was basically 60 seconds, 1 minute, right?
Yeah.
So you just take this, you multiply it by 100, which gives you 0.54, I believe.
Yeah.
So 0.54 upon 60 gives you the force.
Is 9 into 10
is what?
9 into 10 minus 3. C.
That's your average force.
Yeah.
And in fact, we're only going to be doing 10 MCQs per video. So this is it for the, so that's it for this video. Let me just quickly check whether we got all of these questions right. We don't want to misquote anything. Yeah, so far we got all correct, and we'll continue this paper in the next video.